In this project, I am discussing about my Capstone number project number 2, which I am carrying forward from 1, in which there are like 4 types of data set for plant 1 and plant 2. So I am taking plant 1 as a generation data. In this case, I am using k-means clustering as well as random forest for the analysis of my data. So first of all, I am importing the libraries here, the sklearn preprocessing for scaling features. Apart from that, MATLAB plotlib for plotting the graphs or plotting the data. Apart from that, the cluster library for the k-means algorithm. And after that, I have selected specific columns such as daily yield, total yield, DC power, and AC power for selecting the data frames for clustering. And I did the feature scaling as well, so that the scaled features are scaled to have a mean 0 and unit variance, so that it can ensure that each features contribute equally to the distance calculation in the cluster algorithm. After that, I have used elbow method so that I am able to find out the exact or optimal number of clusters. So in the elbow method, the within sum of square is calculated for the range of cluster. Here I have used the range 1 to 11, and the plot method is visualized WCSS against the number of cluster. The elbow point in the plot indicates the optimal number of clusters here. And after finding out the number of cluster, I have applied the k-means algorithm. So in the k-means algorithm, first of all, I did the cluster assignment, in which k-means algorithm is applied using the optimal number of clusters that I have identified above, using the elbow method, and each point is assigned a cluster label, which is then added to the original data frame. And then I have visualized the number of clusters. The x and y basically represent the AC power and DC power corresponding to the clusters. So data points are color coded based on their cluster labels, so that we are able to easily identify how the data is grouped. And apart from that, what I did, I used the random forest, so that I can analyze more easily what are the predicted and the actual values of my target column. In this case, also have first imported the libraries such as pandas, the learn in sklearn, in which I have used train test split, so that splits the data into training and the testing sets, in which I have used 80% and a 20%. Apart from that, I have used random forest regressor, so for the regression, and I have used and mean square and R square for the performance measure. So first of all, I have selected some columns such as daily yield, total yield, DC power, and AC power, and there is a target column which is DC power. And similarly here in this case also have selected the scaled features, so that it has 0, mean, and unit variance. And here what I'm doing is I am basically using 80% of the data for training and 20% for the testing. And in the random forest regressor, what I'm doing, the random forest model is basically trained using the training data, and the model is configured with 100 trees, so that we do have like robust prediction. And after doing all these things, I have used a performance matrix mean square error, which measures the average square difference between the actual and the predicted values. So the lower value basically indicates better performance, and R square represent the variance in the target and the predicted value, and the value basically ranges from 0 to 1, with higher value indicate better performance. So this is the result of my scattered plot. I mean the result in the scattered plot, so that I am able to visualize the relationship between actual and the predicted value. So in summary, I can say that this process basically demonstrate how I'm using my random forest regressor for predicting the actual and the predicted value through various matrices and visualizations. That's it. Thank you.